we solved the question for 41, the decimal number, then we converted it into 101001. This was our final answer of binary number system. Now let us try to solve it. I will tell how to solve that. Okay, the question is, okay, $153. Okay, this is your decimal number system. Okay, see, I must tell you that 0 to 9, that is a decimal number system. Okay, if it is exceeding, then it will come under the hexadecimal or octadecimal. Okay, now we have to convert this. Now what we will do, we will take its factorization as I told you in this question. So let's mention this 1. Okay, now this is our 153. Okay, so as I told you that we have to convert it into binary, so we will do divide it with 2, that is 2, 7, 14, and then 1 carry here, then 2, 6, 12. It gives the remainder 1. Then again we will divide it with 2, then 2, 3, 6, and 1 here, then 2, 8, 16. 0 is the remainder. Again we are going to divide it with 2, that is, I'm sorry, it's 2 1s are 2, 1, 2 9s are 18. Again the remainder comes 0. We have to go till our answer comes 1 in this row or column, you can see this. Okay, so 2 9 times 18 gives the remainder 1. Then again 2 4 times 8 and gives the remainder 1. Again we will do this. Divide with 2. 2 2s are 4, that gives 0 remainder. Then again 2 gives remainder 0. Then this 1 will come here and we will draw an arrow like this. But I'm just telling you this for rough. Okay, only this arrow. Okay, otherwise this process is same, and during your examination you will perform this method only for converting this to this. Okay, so what's our answer? What we will write here, 153 decimal converted into, we will go from bottom to top, then 1 0 0 1 1 0 0 and again 1. Now we will write here base 2. 153 converted to this number, that is 1 0 0 1 1 0 0, then 1. At the base we have written 2. We have did this conversion. Now let us know about the question. If a question came like a number with decimal, means how we will convert this. So it is very easy. Let us know the process. Suppose this is the number which we have been given. So this is a decimal number system. We have to convert it into binary. For binary to decimal, we saw what, giving them here power. Okay, but from decimal to binary, we divided the number by 2. As this is the 41, we divided it, then we got this number. So same it is like, something is same, but yeah, some process is different. Let us see that what it is. Now here you can see that what I have written here, it is FR. FR stands for fraction. Okay, let me write it, fraction. Okay, here also fraction, and this fraction has been divided in it is multiplied with 2. Again here it is our integer. Okay, let me write it. Int stands for integer. Okay, then this is the remaining fraction which is very helpful or very useful to under the process. So as you can see that this is the 41. Now what we have to do, we have to convert it into binary. So it is very simple to convert this 41 into binary. But how to convert these digits into binary? So let us see. 41 we have understood that how to calculate it, so it's not very problematic to solve. So we have already written the answer what we got. Okay, let me show you the actual answer what we got. So here it is your answer. Okay, now let us go for the further process. So this is your fraction. Okay, now we have to take the fraction here. FR stands for fraction. So this is the fraction which is written after the decimal. So we will take 0.625. So just we have to write. This will ease your process. We will make here a column so that clarity gives something like that only. Okay, so 0.625 is your fraction. Now what we have to do, you can see here we have multiplied it with 2. So again we will multiply it with 2, which gives the answer this. Okay, now we have to write the integer part. Okay, we have got this answer after multiplying this number with 2. What we have got, this 1.250. We will write the integer part here, and what we have to do, after writing the integer part, we will write this remaining fraction. Okay, we solved the question for 41, the decimal number, then we converted it into 101001. This was our final answer of binary number system. Now let us try to solve it. I will tell how to solve that. Okay, the question is, okay, $153. Okay, this is your decimal number system. Okay, see, I must tell you that 0 to 9, that is a decimal number system. Okay, if it is exceeding, then it will come under the hexadecimal or octadecimal. Okay, now we have to convert this. Now what we will do, we will take its factorization as I told you in this question. So let's mention this one. Okay, now this is our 153. Okay, so as I told you that we have to convert it into binary, so we will do divide it with 2, that is 2, 7, 14, and then 1 carry here, then 2, 6, 12. It gives the remainder 1. Then again we will divide it with 2, then 2. So let me take one of an example to solve and make you more clarify about it. Now as you can see that this is your decimal number. Okay, and we have to convert it into binary number. So what we will do, as we already know that what is the 41 answer in terms of binary number, but as I am showing you the result or the process again, so what I will do, I will do it from beginning. Okay, so I will again divide it with 2. So 2 to 22. 1 is the remainder here. Again we will divide it with 2, that is 10, and the remainder will come 0. Then again with 2, 5 times, 0 is the remainder. Then with 2, 1 is the remainder, and again with 2, 1, 0 is your remainder. This one comes here, and we will go from bottom to top. Our answer came 41, a decimal converted to binary. We will write 1 0 1, then again 0, then 0 and 1. This is your binary number for 41. Now we have to convert this 0.2 to 5. So as we already know the formula for that, let me partition it to clearly understand. I made the line. Now this is the fraction row. Okay, this will be the fraction into 2. We will write here. We will write here integer. Then here we will be writing what? Remaining fraction. Okay. I have made a clear table for solving this fraction. So our fraction is 0.225. We will be multiplying it with 2. So our answer will be 2 5s are 10, 1 carry, 2 2s are 4, 1 5. Then again 2 2s are 4, 0.450. Our integer is 0 and the remaining fraction will be 0.450. Okay, again we will be writing here our fraction 0.450. That fraction will be written here. Okay, now again we will be multiplying it with 2. 0, 2 5s are 10, 1, 2 4s are 8, 1, 9. This 0.900. 0 is the integer, and then again we will write here 0.900. Again 0.900. We will multiplying it with 2. 0 0, 2 9s are 18, 1.8. Here is 1 the integer, and 0.800 will be. If your fraction will match in later coming steps, then at that time you can pause the process. Okay, so let's begin again. Again our fraction is 0.800. We will be multiplying it with again by 2. 0 0 2 to 16, 1.6. Again the 1 is the integer, then 0.600. Then 0.600 will again multiplied with 2 will give the answer 1.2. Okay, so 1 will be the integer, 0.200 will be the fraction remained. Then again we'll be writing here 0.200, and after multiplying it with 2, 0 0 4 0.400 will be the remaining fraction. Now again we will be doing, see here, 400 and 450. Okay, again we will be writing here 0.400, multiply it with 2, 0.800. The integer is 0, and the remaining fraction is 0.800. Again we will be multiplying it with 2 in this column, that is 1 is the integer and 0.600 will be the. See here only we should stop as this matched with this. So at this process only, at this step only we need to stop. Now as I told you that we have to go from top to bottom, then we'll just make a simple arrow like this and write our final answer, 41.225. This was the question here. Okay, so 10 at the base. After conversion, we got the answer. That was for 41, we got this. So we will write 101 001, then the decimal or the point, you can say. Then from top to bottom, we have to go from top to bottom, serial wise, okay? Then you can write 0 0 1 1 1 and 0. Zeros doesn't matter here, but no problem after writing. So this is your final answer after conversion of 41.225 base 10, and this is the answer in binary. Okay, we have understood this conversion from decimal to binary, but what if given 0.1 binary to decimal? How we will be doing this? Means we know that from binary to decimal we give exponents, or not exponents, but we hold some digits to each digit given, but here it is your decimal. So how we will be solving it? Let us know. Now this is the question which we have to convert binary to decimal. So what we'll be doing here, we will be mentioning, let me take another pen. So for the left part, you will do the same in the way as you were doing for the simple digits. So what we will do, 0 1 2 3. Okay, now for what we will be doing for these numbers, what we will doing, we will be doing -1 -2 -3 -4. Means for our right side we will be giving them negative numbers. Okay, now the simple method as we were performing for the simple representation of binary, in the same way now we have to perform them, but you need to keep these in mind. Okay, so let us do that. One into 2 to the power 3, add it, then 0 doesn't mean anything, so we will leave it. Then 1 into 2 to the power 1, and again 0. Okay, then plus, don't write here decimal during your processing. Okay, then what will be taking, 1 multiply it with 2 to the power -1, then again plus, then 1 into 2 to the power -2, then plus 1 into 2 to the power -3, then 0. Now simply we have to just multiply them. So what we will do, 8 here, then plus 0 plus 1 into 2, that is 2, 0. Here 1 upon 2 comes now, so 1 into 1 upon 2 plus 1 into 1 upon 4, because at the base the power gets means positive, the power will become positive. Okay, then add 1 into 1 upon 2 to cube. I just show you something like this. This is your 0. Okay, sorry. Now just only I have written these and the next step. Okay, 8 here written, and 0 whatever was I left them. Okay, now what we have to do, 10. Now 8 plus 2, 10. Okay, 1 upon 2 comes 0.5, and 1 upon 4 comes 0.25, then 1 upon 8 comes 0.1, 1 to 5. Okay, this is your Now just we have to add them. So 10 plus, just add these decimal numbers. Okay, 0.5 at the third place, then second place is 5 plus 2, 7, then first place 1, 2 and 5, 1 plus 2, 3, then 5, 8. The final will come 10.875. This is your 10. After getting the final answer, let's write this 1010.1110. Finally converting it to decimal, 10.875, the base 10. Okay, this is your final answer. Now we have learned the complete binary to decimal and decimal to binary with a point also for both the topics or the conversions. Okay, now let us begin with the hexadecimal, which is written like this, 16 at the base. Okay, so let's begin it with notes. Okay, so this is your hexadecimal number system. As you can see, this is represented by 16 at the base. Okay, the base of hexadecimal number system number is 16. Okay, in this number system, digits 0 to 9 is used, followed by A, B, C, D, E, F. Now I should always tell you that 0 to 9 will be the perfect, means no need to worry for these digits, but you need to see this A, B, C, D, E, F. They are what, like, can you understand? I have written them with a light pen. Now let us see that. As it is hexadecimal, so it will go to 0 to 15. Okay, so how we write it? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But what for 10? Let me write like that. Okay, 11, 12, 13, 14 and 15. Till 15 it will go. Okay, so 0 to 9 is all okay. We will use these digits, but from 10 onwards, what we will do? We will use it as A. Okay, 11 as B, 12 as C, 13th as D, 14 as E, and then 15 as F. So A to F, these alphabets are used, but only in capital letters. Okay, are used to symbolize these digits. Okay, because it's not easy to write for a representation, so for our easiness we just use these. Okay, as these are single digits, but these are double, means 2 digits numbers, so no problem, we will use these letters to signify them. Okay, same as that it is telling you here what I have written: 10, 11, 12, 13, 14, 15. Okay, now 16 will be converted to decimal. So what we have done here, I'm just giving some examples to you. In the next coming video we will be converting, we will do the conversion related to this hexadecimal. Okay, so let us see this 4B8. So first of all, you should see that what is B actually. So B is your 11, as I told you. So we have to convert it into decimal. Okay, so as if we have to convert it into decimal, we will multiply it. Okay, but with 16, and at the exponent we will be using these, like when we were converting binary to decimal. Okay, same when we were okay, so now we have to convert hexadecimal to decimal. So 4B8, B is your 11. Now we will give them numbers 0, 1, 2. So 4 into 16 to the power 2, then 11, which is to the power 1, 16 is to the power 1, and 16 to the power 0. So multiplying 16 square with 4, then we get the answer 1024. Then 11 into 16, simply we got 176, then 8. 16 to the power 0 means 1. Okay, this only means 1, only this one. Okay, so we got this, we will add them, and then our answer came 1208 with decimal, same as like that. 6e, e for 14. Okay, e for 14. 6 into 16 to the power 1, 14 into 16 to the power 0, and after adding them we got the answer this. So we have understood the hexadecimal number conversion. So, and this was your hexadecimal number system. In the next coming video we will be discussing its conversions. As I told you an example, I will be solving it in the next video, as well as in the coming video I will also discuss the octal decimal number system, which is symbolized with 8. Okay, so I should first discuss it, but actually the notes were available for this before this one, so no problem, I will provide it for sure. Okay, so this was all from my side. You can again take the recap for this system. That was all. Thank you.